Hi guys, and welcome to Introduction to Mechanical and Automotive Engineering. I'm your lecturer, Dr. Elizabeth Kyriakou, and now it's week 3 of semester, which means we have a 5% online quiz. And to find the quiz, it is in Canvas, and please make sure you answer the questions in Canvas. So I thought it would be nice if I actually went through the problem a little bit with you and give you some handy hints. But you know, it was quite a nice weekend. The sun was out, it was nice and warm. So I thought I'd take the Volvo out, get my boat attached to it and go down to Port Melbourne and hang out on the water. However, I think I have some problems here because I can't quite afford a trailer. Let's take a look at the question. So the question says, my car has a mass of 4,000 kilograms with a centre of gravity at G. The coefficient of static friction between the boat and the ground is 0.25, and between the rear wheel of the car and the ground is 0.95. The front wheels are free to roll. The car is about to start, hence it is stationary. The car and the boat wants to roll down the inclined plane. So just a couple notes. It's a two-dimensional problem. We only have 2 wheels on my car, and we're going to take gravity as 10 meters per second squared, and can we please keep our decimal point places to 2, just to keep the calculations simpler. So let's just take a look at what we have, what we know. So I know that I have a mass, mg, of the car. Let's just draw that in. The car wants to roll down the plane, so therefore we have motion going this way, so we're moving downwards. Which means friction is going to go up the plane. So here we're going to have friction at the boat, Fc. At the rear wheel, we also have friction, Fa, so we'll just draw it in here. And we know that the front wheel is smooth and free to roll, therefore there is no friction. So what else do we have in this problem? We have some normal forces going on at A, between the wheel and the surface of the road. So we'll call that NA. And at B, we have the same thing. So here we have NB. So between the wheel and the road and the ground. So if we take a look at the boat, what do we have going on over here? We have a normal force between the boat and the inclined plane. We'll call that NC, and the boat is also going to have a mass of M boat G. Okay, so we actually have quite a few unknowns. I think the next thing I should do is write out my equations for equilibrium. So for equilibrium to occur, some of the forces in the x direction has to equal 0. Some of the forces in the y direction has to equal 0, and some of the moments around a point has to equal 0. So I have 3 equations, but I have 1, 2, 3, 4, 5, 6, 7 unknowns. So I need to do something else to actually break this problem up into. Well, the first thing I'm going to do is, to make this problem simpler, is to rotate my xy axes to sit parallel and perpendicular to the inclined plane. So we'll just draw that in. Okay, what else do we have? We know that there is a rope between the car and the boat. So let's take a look at this over here. If I cut that rope, I'm going to have tension from the car, T, and I'm going to have a tension from the boat. So what do we have to remember when we have this kind of when we're cutting the rope and we have tension on either side. So these two tensions need to be equal and opposite for my system to remain in equilibrium. So how are we going to solve this problem? I think we're going to break it up into two problems. So here we have the car, and here we have the boat. So basically I need to find T and put it into the other free body diagram. So shall we draw a free body diagram? So I'm going to draw two free body diagrams, one for the car and one for the boat, and then I'm going to solve them separately. So here we have our inclined plane, and this is my car. This is point A, point B, and here is G. So we know at G, and oh hang on, here's my 20 degrees inclination. So at G I have mg, and the question tells me that my mass is 4,000 kilograms. So I'm going to have mg equals 4,000 times 10, which is going to be 40 kilonewtons. To keep these problems simpler, I'm just going to make sure that I keep everything for now in kilonewtons. So we have mg, and that's going to be 40 kilonewtons. What else do I know? I know that I have two reaction forces at A, NA, and NB. And I also have friction at A. And the last thing I have in this question is I need to include the tension in the cable, T. So now I need to solve for NA, NB, FA, and T. So we actually have three unknowns because FA is going to equal mu A NA. Let's take a look. So this is the car. Let's take a look at the boat. So over here we'll draw the free body diagram for the boat. So here's my inclined plane, and here is my boat. And I have a normal reaction between the surface of the boat and the ground. I have friction that's going up the plane, and I have M boat times the gravity. And finally, I need to include this tension. And T. So we're going to find T in here, and we're going to make sure that it's equal and opposite in this question, in this free body diagram. So in this problem, the only thing that we're missing out on is our dimensions. So between the ground and the centre of mass of the car is 0.65 metres. Between the rope and the ground is 0.48 metres. The distance between G and B is 1.1 metres, and between A and G is 2.2 metres. So I think I can solve that now. I've got three equations, I have three unknowns. I can find T. I can take T and put it into the free body diagram of my boat and make sure that it's equal and opposite. And then I can actually calculate and find NC, which means I can find the frictional force, and what I need to find is the mass of the boat. So give that a go, guys. See how you go, and I'm sure you'll be fine. But don't forget to upload your solutions to Canvas. Good luck.